Hello, today I'm going to describe you how to implement unit testing, which is driven by the application itself. Whenever you have application and you have developed some sort of testing framework on top of that one, and typically the testing is performed either on your own machine or on some virtual build machine, so where the build occurs actually. But this does not correspond to the actual end user situation. So end user might have completely different Windows installation, and application could behave there completely differently. Also, testing framework does not allow easy deployment to the end user machine. Also, Visual Studio Test Platform does not allow to start up your application from the main thread, so it can only execute from the side threads. Alternative to this could be that we develop some sort of test adapter according to Visual Studio Test Platform specification, which leads to more complexity. And as a host application, you are either using test host exe for 64-bit platform or test host x86, which is correspond to 32-bit platform. And basically this is not the same as your final application. So test framework itself has its own problems. So one code change might break multiple units or integration tests, and in worst case scenario you need to alter only one code, and after that fix hundreds of lines of test framework itself. Moreover, exception messages, which if you are providing, for example, some sort of API or SDK to third-party developers, so those exception messages should be developer-friendly or user-friendly, containing rich information about the error itself. And so besides the testing of functionality, we need to test the exception messages as well, so they contain rich information. Visual Studio Test Platform can be downloaded from Github, and it's basically open source code project and licensed by mid-license. But as a side effect, it is complex and it is not bug free. It has a lot of glitches and sometimes it just hangs. And to my best understanding, it's the complexity of platform itself is reflecting that it is not so stable. Execution starts from non-main thread, so UI testing is not identical to actual UI application. So cannot be made portable, so it cannot be deployed on client machine. Actually, it could be deployed, but you need to pick up a lot of assemblies for that one. Debugging is actually really difficult because from time to time it tends to launch separate process, and in order to debug that one you need to debug that separately launched process. There exists good alternative which is Google unit testing, and for that one there exists Google test adapter, so I will shorten it to GTA in next slides, and it is developed by Christian Soltenborn, so German Google, and main target for that one is C++ programming languages. And what is good about this testing, it's basically concept changes. So basically test application is Windows console application, so it's basically like standalone application which can be launched and can test itself. Bad is that it does not support that, or actually I have added support for C# language, so it did not support C# language. but there is still differences between your own like official application and test application. Google Test Adapter resides on GitHub in this repository, and Microsoft has created its own fork for that one, and it's named it slightly differently, so it's named like Test Adapter for Google Test. And both exist on Visual Studio Marketplace, and they are actually two Visual Studio extensions which are conflicting with each other. Microsoft fork add more support, so it actually adds some project template for simply creating Google unit test project. And original Google Test Adapter is actually, I could say that it's more advanced than the Microsoft fork at the moment, but it does not have those project templates. I have managed to create my own fork from the Google Test Adapter, and main purpose at the moment to add C# programming language support. So basically changes which I have made is that you can actually attach to the native code, so C++, but also you can attach to managed code as well, so C++, CLR and C#. Report correctly C# call stack, so whenever there are exception occurs, and actually being able to report on which source code line and test method your test resides in. And I have plans to merge this with the Google Test Adapter itself. And if anyone wants to try it out right now, so I have placed a link for the temporary 0.70 build. So basically how Google unit testing actually works. So application itself is actually console application, and it's executed by the Visual Studio, so from Text Explorer, and it's actually using Google Test Adapter as Visual Studio extension, and that in turn actually is launching console application. So like launching and monitoring its output. And there is two kind of execution scenarios. So first of all, it is getting a list of unit or integration tests. So it's actually using the command line get test list tests. And whenever you are starting the testing itself or debugging, so it launches same application with the different command line parameters. So typically those are like specifying the report file for testing, specifying filter, so what kind of classes or methods there will be executed, and some additional parameter to control test execution parameters. So if you want to try out the Google unit testing, you just go tools, extension and updates, and go online, and from there you search test adapter, and actually so here actually are those two extensions. So this one, so they are both identical more or less, but this test adapter for Google Test, it contains project templates, and this is the original Google Test Adapter. So I'll just install this for now, just to show you how the C++ unit testing works actually there. Okay, so you need to restart your Visual Studio, so I will close it and restart it shortly. So here is my Visual Studio after starting, and if I go again in Tools, Extension and Update, and I can see actually that this test adapter for Google Test is installed and its version is 0.10. And if I want, I can create now the project itself, so I can go in C++ test Google Tests, and I could just pick up here some folder, and let me create sample test 1, and I'll use just default settings here. And from test menu I can find Windows and Text Explorer, and this will actually display me sample test 1, and class name, test case name, and test name is actually the actual test. And I could actually run now, right click and try to run selected test, so it simply executes those tests. So if you are interested to see what is happening behind the machinery, I could add some additional code snippet with default with one class and default constructor executing a message box. So basically the purpose of this message box is simply to display what kind of command line arguments the given executable receive it. So I could simply save it and recompile it. And what I will see after that is basically Visual Studio will launch my application with some specific command line. So I'll simply compile it, and I can see that it's actually popping up that it actually Test Explorer is requesting what kind of test my application has. So, and then it basically displays them in Test Explorer. Let me disable this additional message box for now. I'll recompile it again, and I could actually go in the project folder, and I could actually launch command prompt from here, and then I execute get test list, and actually it tries to correct me what kind of command I could use here. So if I launch sample test 1, it gives me a list of test names here. Now if I want to run all those tests, I can simply launch that executable without any additional argument, and then it will be actually running those tests and actually measuring how much time each test takes. So basically whenever tests are executed, so console application itself is printing all the information and error messages to console window. And basically Google Test Adapter monitors that console window and updates status to Test Explorer. So basically test application itself need to print in that special format which Google Test Adapter can parse and comprehend. So for example, whenever there is a test is actually launched, it's marked as a run, and if test succeeded, so without any exception, so then it's okay. And it's could be also here some fail or skip it, and between those run and okay, so there could be some additional printing which you are printing to the console window itself. Next we are going to test C#, and for that one we need to go into extension and updates and install Google Test Adapter. So that was that previous link which I have gave you, so it should be like 0.70 version. And besides this one, we need to disable also Microsoft Visual Studio Test Platform, because it is not working very well with the Google Test Adapter, and there is still some probability that they will work together, but I prefer not to take any risk, so you just disable it and then restart the Visual Studio again. And basically in similar manner we will have also test fail it, pass it, or ignore it. So depending on the test itself, so for C# test as well. And as a demo application I'm going to use that one test C# classic console application which resides in the Google Test Adapter Git. Now I have opened Google Test Adapter, and here under test you can find test C# classic. So classic actually refers to fact that we have here some class with the test class and test method. And by default it does not appear in Test Explorer until you actually compile that test application. So after compilation it launches Test Discover, and after that we will get our tests uh, from the source code to the Test Explorer window. And in similar manner to C++, so we can just run those tests, and these tests are currently just for testing that Google Test Adapter is working actually with C# classes as well. So you can click here and see also some additional information on used call stacks as well. If you want to check a bit deeper how this classic test method is implemented, you can actually go to definition of test method attribute and actually find out that it's actually defined in here, as well as other test attributes as well. So ignore attribute, test class attribute, and other attributes as well. And here also exists some mechanics, so how those individual tests are called. And for example, if I want to check through so how this asserts fail actually works, I could place the breakpoint on asserts fails and also on the main itself, and right click from here and debug selected tests. So basically it will launch my application with some specific command line arguments, so it provides those arguments inside. And by pressing continue we will actually reach our function, and you can see the whole implementation, how it actually works. So basically test main is actually resides in Google Test Bootstrap, which in a turn uses traditional unit test info, and from there info comes in our function. And if you want to see how the execution proceeds further, so we have here some assert equal, and it in a turn will try to throw an exception. Exception will execute all test cleanup method call, and after that we could actually return, and it will get called by exception handler. So basically if you want to see to catch an exception which is not known exception, you could just place the breakpoint in here, so in Google Test Bootstrap. But it's also possible that exception type is known and it is not considered as a failure itself. This was a little bit about classic testing approach, and now I would like to show you more advanced stuff. So we will go into use Google Test Adapter and C#, and actually we will go into use C# scripts in itself. So this exists as a sync project, a Github project, so it's command line utility for generating C++ scripts. And tests are basically not integrated in the application itself, so they resides as a separate C# script files in the file systems, and C# scripts are actually compiled on fly by sync project, so command line utility, and source code path is known, so we basically know where that source code resides, but where the main starts up, it is not known at that point of time, because it is not necessarily compiled, so we report as first line, so it's always one. And there is no asserts AQL approach, so that testing framework is not using any asserts whatsoever. It only uses console write line. And basically, if we compare it to existing testing frameworks, so we typically have asserts equal A and B, and basically it would correspond that we would write console write line A and accept test results of B, so everything that is being printed, it will be saved to file. Now I have taken the project from the Git, and I will try to compile it, and test will automatically appear here, and like you see, beside the test file name itself, I have added here additionally file format extension, just to be able to see what those files are actually. So basically the file format extension defines what to do with that given file, and this is now applicable to sync project itself. So but if you have your own application and you could have different file formats supported, you could have, for example, import or something else, so the behavior logic could be completely different. But basically you could list them through in your own as a file in here basically. And for the sync project itself, so C# files are basically means that those will be compiled to assembly and executed, and whenever the output that C# script produces, it will be compared against what was previously accepted. And for batch files and solution files, the behavior is slightly different, but logic is the same, so we are still comparing something against some previously accepted results. Unit test is basically self-coded function which actually compiles C# script and executes C# script main, and main can perform some printing, so it can produce console write and generate files, and generated console output and generated files are compared against previously accepted files. So I have written like reference files, but it's basically previously accepted results. And basically what is good about this kind of approach is that there is no special unit test for everything. So unit test is basically some C# script, so the application itself, and which execution outcome is basically accepted or not accepted. So basically you can just write some script and just accept whatever the script itself will produce. Basically, whenever I need to write the new unit test, this basically means that I'm going into test folder and copy some existing C# script and modify it according to new needs. So for example, I could perform some new operation which was not previously there. And C# script is basically console application which does not have its own project, and you can use Visual Studio C# script extension to open and execute that one. And basically that C# script can also reference some custom assemblies or system assemblies, and it is using special kind of syntax for doing this one. So it's additional comment at the beginning of C# script itself. C# scripting support can be downloaded from the following links, and Visual Studio extension can be found behind this link. Sync project has built-in C# script support, but it's a matter of compiling .NET assembly, nothing special. So let's pick up some demo C# script. So for example, we have here C# script to project, and here is the project itself. It is always reported as line 1, so it always jumps over here. Theoretically, it could go also to the main, but I don't think it is so much difference in that sense. And if we check through where that project resides, so that scripts actually produces some sort of console output, which will be recorded in this file, and a lot of project files which reside this as accepted files. And if we try to modify here, so for example, I'll just add here some assembly right line, and then I will add it here, okay, and I will try to execute the same test again, and then it will notice that actually test results differs, and this is really minimalistic user interface for this kind of accept reject behavior. And then if I click no, then I can just check what are the differences. So there was previously only this kind of output, but now since there is for loop, it's printed out 8 times OK message there basically. And after that I can either cancel, and so if that OK message was not acceptable from my perspective, I could press cancel and go fixing the code, or I could just accept the test results. And this in turn means that this accepted log was updated, and I can see actually using git diff I can see those differences here as well. And also I could check through what kind of source code modification I have done. So basically adding this additional one line here resulted in change of accepted log in here. Also, what I wanted to demonstrate you is that normally when you launch application, it could be just a console application which performs a magical trick, and testing itself is hidden behind some command line parameters. So for example, I could run test, and then it would actually start performing those tests. And I have now also integrated inside the Google Test Bootstrap as well. So in similar manner, I could just check it through. So I could use, for example, test list, or simply tests to lists what kind of tests are inside my application. So it prints out everything, all tests. So this output is used by the Google Test Adapter to propagate those tests to the Test Explorer. And if I want to execute, I could use directly -test or -t parameter, And if I want to have it in formatted as a Google uh, te test output, so I need to use additional parameter for that one. So I will execute testing approach and put report in the XML file. So then this will use the traditional way of executing those tests. So basically, whenever you are accepting the test results, it means that generated console output will be saved in some special file, and generated files will be renamed to accepted and will be used to verify that test results did not change in future. Here is the same kind of diagram. So basically C# script itself and C# script console output and files which are generated by the C# script. And basically those two are in sum gives accepted test results. So if we compare these two testing approach, so using classic unit testing, you cannot write unit tests for the user interface, and tests are usable only by the test framework and only by developers. And if you write the unit testing using C# scripts instead, so those tests can be used by the end users as well. So for example, to automate your application, and there is no separate assert class usage, and C# can be executed normally only. So if you execute it, it produces some output or controls your application, but in case of testing, it's also verifying the outcome of C# script execution. And end users also can use scripting to automate their daily tasks. If we talk about future, so at the moment using Google Test Adapter, tests become visible only after you compile your application. But theoretically, a test could reside completely out of application, so you could use application as a test application, but tests are still resides outside of it, so they can be as C# scripts. And basically we might need in future some mechanism to indicate to Google Test Adapter and to Visual Studio that we have new test cases coming in. Also, when testing application itself, we don't necessarily need to start and shut down the application itself, so it could be up and running, but we need only to execute test on that application itself. So theoretically we could actually just force Visual Studio to attach to that executing process and start testing, and then communicate test results back to the Visual Studio, and we don't need even to close or terminate the process itself. C++ scripting support is also not excluded. So currently there exists, for example, for non-Windows platform, there exists C-Link, which is actually C++ interpreter. Unfortunately, that one is not debuggable on the Visual Studio level. But there is also exists this kind of C++ runtime compiler, so which is able to compile C++ on fly and execute it immediately. So in theory, in future we could have also C++ scripting support.